What's up, y'all? I'm Tom, and this is Like a Math Class. In this video, we're going to continue our discussion of data and finding the measures of the center of the data, and we're going to graph it. But in this case, we're going to be looking at what's called continuous or measurable data. Let's get to it. As mentioned, continuous data simply means measurable data. Measurable data would be something like time, or weight, or height, or distance. All these things are things that you need to use some tool to measure. So therefore, it's continuous data. And if we had a more accurate tool, then that data could continue to be broken down. So might be looking in kilograms, or we might be looking in grams, or maybe fractional grams. Milligrams? Milligrams. So we just keep on breaking it down depending on how well our device functions, how accurate our device is. So that's why we call this continuous data. If you notice here, we have a set of data, a set of our continuous data. I pulled this from the Core Topics textbook from the Hayes Mathematics publishers. And this shows petrol sales in one day by a number of city service stations or petrol stations or gas stations, whatever you want to call them. And over here, we've got all of these different things here, these liters, the petrol in liters, and each one of these things are called classes. Classes are groups of data. So we may not know the actual data amount for these 4 sales or these 4 sales or these 9 sales. We don't know if it was 2001. We don't know if it was 2,999. We just know that it falls within this class or this range or in this grouping. So if we want to find the central tendency, that means we have to find what's called the modal class. So we're looking for the class that has the most data items. And as you can see here, this is our modal class right here. Right? This one is our modal class. So 6,000 is less than P is less than or equal to 7,000 is our modal class. The second thing we want to find is our median. Now in previous videos where we talked about median, we said we needed to find how many data items we have, add 1 and divide it by 2. So if we do a quick count here, I'm going to start down here. That's 39, 49, 53, 62 plus 8 is 70. So I'm going to have 70. So I'm going to have 70 plus 1 divided by 2, and that's going to be 35.5. So to find this, it's going to be between the 35th and 36th data item. And the 35th and 36th data item is probably going to fall somewhere up here. So if we've got 70 items, we have to find the halfway mark. So here and here, this is 39. So 39 data items. So that means if I'm starting at this end and I'm working up, it's going to fall in this grouping. Or if I go this way, 8, 17, 27, 31, 35, right? It's gonna 35 and 36 are gonna fall in this range. So our median is going to be something inside the middle of this. Since we don't actually know what the data values are in each of our classes, when we're trying to find the central tendency, when we're trying to find the median, when we're trying to find the mean, which we'll do in a second, we always use an approximation, and we use the center of the class as our approximation. So in this case, that's kind of easy to find. The center of each of these classes is, here we've got 2,500, 3,500, and so on, which means that our median is going to be approximately 6,500 liters. That's going to be our median. Now, what about our mean? If you remember, our mean is our arithmetic average. So we're going to use an approximate by using this center or the midpoint of this data. So to find the mean, I'm going to use the frequency as well. So I'm going to say 4 times 2,500 plus 4 times 3,500 and so on. And what that's going to do is that's going to allow me an opportunity to quickly calculate these values. So let's pull open our calculator and see what we've got. 4 times 2,500 plus 4 times 3,500 and so on. That gives us a value of 411,000, and we already counted to say that we've got 70 items here, so we're going to divide that by 70, and so we get an average of approximately 5,871. So our mean is going to be approximately 5,871 liters. There's our mean. And this is all well and good. This tells us a little bit about our center. We're kind of hanging out up in this area for our center. But what does this distribution actually look like? I've got a graph started for us down here. And what we have on this side is the amount of petrol sales in liters, or the amount of petrol sold maybe. And over here we've got our frequency. So what I'm going to do is I'm going to do a little bit of a cheat. I'm going to have a nice long horizontal line here because I can do this so that way I can make a nice clean graph. So our first one is going to be at 4,000. Our second one is also going to be at 4,000. And then our third class was at 9. So I'm going to go right up here to 9. And look at that. That's the joys of technology. And then after 9, I've got 14. And then I've got 23. And finally, I've got 16 for my last one. Let's fill this in to make it look a little bit nicer, right? We want to have a nice colored in graph here. If we go back to what we talked about in previous videos, this looks like it's got a tail kind of going out this way, which means that this data is negatively skewed. Or skewed left, sometimes we say. And then, so our mean, our median, and our mode. Our median was in this class about right here, right? Our mode was also in this class, and our mean was 58 and some change. So that's going to be about right here-ish. You know, these two values you could probably put right on top of each other if you wanted, but I kept them just slightly separated because A, I know that this thing is not exactly in the center here. We use that as an estimation, but even if we're looking at the number of data items, it might be pulled over this way just a touch. But our modal class is this whole thing. So maybe even I should have this whole thing covered blue. But that's roughly, and that follows about what we normally see with a skewed distribution. The mean is pulled more towards the extremes. The median is just ever so slightly nudged off to one side. And then the mode is always in that peak. And so I've plotted in all of this data in here, and as I put this central tendency, but I didn't really talk about why I've got these things like this right next to each other. If you remember from our discrete data, we had little separations between each one of these bars. And the reason that we don't here is because this is continuous. We could, in theory, have 3,000, 0.001. We could have 2,999 liters, 0.9 liters. You know, we could have everything that runs the entire spectrum within that grouping. And we don't know where we're at. So we put all of our bars right next to each other. This thing is called a histogram. So it's when you have a bar chart for continuous data, that's called a histogram. And histograms are always bumped next to each other here because the classes all continue from one to the next to the next to the next. There's no gaps in here anywhere. Our histogram has no gaps either. So that's how we graph continuous data. That's how we find the mean, the modal class, and the median of this, or the approximate mean, I should say. And I hope that was helpful. If it was, make sure you give me a thumbs up. Help spread this out to other IB students and other math students across the YouTube universe. And I will see you in the next video.